In this video, we will begin our midterm 2 review. So our goals for all of the videos in this section is to do practice problems to help prep for that midterm. So in this video, we're going to focus on an example where we graph a 3D surface. So the example is, let's sketch 9x squared minus y squared plus z squared equals 16. Okay, so at this point, I want you all to pause the video for about 3 to 4 minutes to try this question on your own first. So 4, 3, 2, 1, pause the video. Pause the video for about 3 to 4 minutes to really try this question. So during the actual exam, or during any quiz or exam that we take in our class, you're going to be solving new problems. So it's really valuable to practice that skill, practice solving new problems. So in this video, when we're posed with this example here, really take advantage of this time to pause the video and try the question on your own. All right, so hopefully you've done that. Hopefully you've paused the video for about 3 to 4 minutes to try this. And there's probably not going to be enough time to finish the problem, but I mostly want you to think about how you would begin and what are the key steps. So we need to look at the cross sections. Looking at the cross sections can help us graph this. So typically when we look at the cross sections, we begin with x equals 0, y equals 0. Let me put commas between these. X equals 0, y equals 0, z equals 0. We typically begin with those. So in other words, we ask ourselves, when does our surface sort of meet our coordinate planes? X equals 0, and then y equals 0, and z equals 0. All right, so I'm actually going to begin with z equals 0, just because I think this is, out of the three, this is the most complex one. So I'm going to start with this and really show my work on how I get this cross section. And then for the others, I'm going to go a little bit more quickly through the algebra. Okay, so for z equals 0, if I plug that in, we get 9x squared minus y squared equals 16. All right, so at this point, hopefully we can recognize that this is a hyperbola graph. This is going to be the graph of a hyperbola. So the main things that we try to find with a hyperbola graph are first the intercepts. So in this case, let's find the x-intercepts and the y-intercepts. So for the x-intercepts, we set y equal to 0. And if we set y equal to 0, we get 9x squared equals 16. X squared equals 16. Let me write that 2 a little better. X squared equals 16. And then if we isolate for the x, if we divide by 9 and square root both sides, we get x equals plus or minus 4/3. So the x-intercepts are going to occur at positive 4/3 and negative 4/3 on the x-axis. The y-intercepts, they would occur, we find them by setting x equal to 0. And if we set x equal to 0 in this equation, we get negative y squared equals 16. So this equation is not going to have a solution. It has no solution. Because if we move the negative over to the right-hand side, we get y squared is equal to a negative number. And that just can't happen. Y squared can't be equal to a negative number because y squared is always non-negative because of the squared. So because there's no solution to this, it means that there are no y-intercepts. All right, so we find the intercepts. Those are going to help us graph this hyperbola cross-section. The other thing that we look for to help us graph a hyperbola are the asymptotes. So the asymptotes. So the way you find the asymptotes of a hyperbola when it's in this form is we change the number that's on the other side of the equation. So that doesn't have the variables. So we change that 16 to a 0. Because when we talk about asymptotes, we're focusing on what happens at the edges of the graph. So as x gets really big, goes to infinity or negative infinity, and same thing with y. And when the x and the y values get really big like that, the number on the other side is negligible. So I'm going to change that 16 to a 0. And if we do that, we end up with 9x squared minus y squared equals 0. And if we rearrange this, we get y squared equals 9x squared. And now I can square root both sides. And doing that, we get two different things. We get y equals 3x and y equals negative 3x. Okay, so those are going to be our two equations of our asymptotes here. Okay, so let's graph this. Okay, so I'm going to draw some axes. So draw some axes. So this is going to be my x-axis, that's my y-axis. So if I plot the let's do the asymptotes first. So the asymptotes are pretty steep lines. The slope is 3 for one of them, so y equals 3x. And then y equals negative 3x. This one has a slope of negative 3. And if we draw in the intercepts, so the intercepts occur on the x-axis. So there's 1 when we reach 4/3 on the x-axis. There's 1 when we reach negative 4/3. And now when I draw on the graph, I have to draw the graph so it sort of snuggles up next to the asymptote this way and snuggles up next to it that way. And same thing on the other side. Starting here, it's going to snuggle up next to the asymptote this way and snuggle up next to the asymptote that way. And that's my cross-section. That's this cross-section when z equals 0. All right, so let's also find the cross-sections when x equals 0 and y equals 0. All right, so x equals 0. So if we plug x equals 0 into our original equation, we will end up getting negative y squared plus z squared equals 16. And this is another hyperbola. So this is another hyperbola. But I mentioned before, so if I zoom it out a little bit, I mentioned before that at the beginning that I was going to do the cross-section when z equals 0 in complete detail. And that's what we did, because that's the most complex one, at least in my opinion, for this example. The other cross-sections, x equals 0, and when I look at y equals 0, I'm going to do more quickly. I'm going to go through it more quickly with that algebra. Okay, so for this one, I'm just going to say what the intercepts are. So if we find the y-intercepts of this, there are actually none. There are no y-intercepts for a similar reason as in the previous cross-section, previous hyperbola. For z-intercepts, z is going to be equal to 4 and negative 4. For the asymptotes, we are going to do the same thing in terms of what we changed the 16 to. We would change the 16 to a 0. And when we do that, after we do some work, so I'm going to put dot, 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 this is after we're doing some work, we end up getting that y could be equal to z and y could be equal to negative z. So those are our asymptotes. So one more time, in this whole situation here, and in these steps, I skipped steps here. I skipped steps and I just said the answers to a couple of these. But you should show all your work. So if a problem like this was a test question, you should show all of these steps and not just the final answers. I'm choosing to skip them here in the video so I can spend more time talking about the heart of the problem, which is taking these cross-sections and using them to draw the 3D graph, and less time on the algebra. Okay, so that's x equals 0. What about y equals 0 now? So y equals 0. If we plug y equals 0 into the original equation, so let me zoom it out a little bit so we can see it. So if we plug y equals 0 into the original equation, we end up getting 9x squared plus z squared equals 16. Okay, so that's what I get when I plug in y equals 0. So this has the shape of an ellipse. An ellipse. It looks a little bit weird when I zoom out and I write it. So let me write this a little bit better. That's 16. That's z squared. And the 9x squared I think looks okay. Okay, so this one with an ellipse, we would find the intercepts. Those help us graph it. So the x-intercepts in this case, and the z-intercepts. If we find the x-intercepts, it turns out what we'll get is that x can be plus or minus 4/3. And for the z-intercepts, it turns out that z can be equal to plus or minus 4. So if we take this information and now graph the ellipse, okay, I'm reaching kind of the bottom of the page. Let me fit it in here on the side. So if I keep track of the x-axis and the z-axis. Okay, so in the z direction, the intercepts are at 4 and at -4. In the x direction, they're not spaced out quite that far. So I'm going to end up having a narrow-looking ellipse, where this positive x-intercept happened at 4/3, where this one on the negative side happened at -4/3. And that's what that cross-section looks like. And you know what? I think I never drew our second cross-section here. Yeah, so for this hyperbola, it looks like I just skipped that one. Let's go ahead and draw this one. All right, so I just shifted over the writing here a little bit to give myself some room on the side. So if we draw this one in, so I'm going to draw some axes. And for this one, we'll have a y-axis and a z-axis. And our asymptotes were y equals z and y equals -z. So those are lines of slope 1 and slope -1. And this one did have z-intercepts. So there's a z-intercept at 4 and a z-intercept at -4. And then from those intercepts, we have to snuggle up the graph next to the asymptotes. So in that direction and in this direction, and the same thing down at -4. Snuggle it up next to that asymptote, snuggle it up next to this asymptote. Okay, so we have our three sort of initial cross sections. So we were trying to graph the surface given by this equation. So once we have those sort of basic cross sections from the coordinate planes, then we get a few others until we can start to see the shape of this graph. So get a few other, let me write it like this, get a few other cross sections. So usually we do this by setting one of the variables, like either x or the y or the z, equal to different numbers besides 0. So maybe plus or minus 1 or plus or minus 2 or and so on. So how do we choose which of those variables, either the x or the y or the z, that we should do that with? So it's best to choose a variable with simple cross sections. So in this case, when we set each of those variables equal to 0, with two of them we got hyperbolas, and one of them we got an ellipse. So the one that we got an ellipse for was y. So if we set y equal to stuff, if we set y equal to some number, then this gives us ellipses. This gives us ellipses. And in general, I would say that ellipses are easier to deal with than hyperbolas. I personally feel like they're easier to graph in 2 dimensions, and because they're easier to graph in 2 dimensions, I definitely feel they're easier to graph in 3 dimensions. Okay, so I'm going to pick y because I found that it had the simplest looking cross sections, and let y be equal to some other numbers. So if I let y be equal to plus or minus 1, and I'm doing both of them at the same time, because when I plug them into y squared, I'm going to get the same number, which is kind of nice. So that'll save us some time. If we plug it in, we get 9x squared minus y squared plus z squared equals 16. And now if we plug in for the y, if we plug in plus or minus 1, if we work this out, we'll get 9x squared plus z squared. And then plus or minus 1, when we square it, is 1. So we have this minus in front of it. And if I move the -1 over to the right, we'll get that this equals 17. Okay, so we get this equation, and this is an ellipse. This is an ellipse. Okay, so now let's do a few others. What if we did y equals plus or minus 2, and we plug that in? Well, then we get 9x squared minus y squared plus z squared equals 16. So let's plug in our y values. So we're plugging in either plus or minus 2 in for the y. And now this gives us 9x squared plus z squared. I'm going to write those two terms first. And then after we square plus or minus 2, we get 4 for either one. And then if we move the negative 4 over to the right, we get that this equals 20. And this is going to be yet another ellipse, but a bigger one. The fact that we have a 20 on the right-hand side instead of 17 is going to make this a bigger ellipse. So one way we could see that is if we just think about what we get when we find the intercepts. The intercepts of the ellipse when it equals 20 on the right-hand side are more spread out from the origin, from 0, than they are if we have 17 on the right-hand side. Okay, so in fact, if we start to draw some of these ellipse cross-sections. Okay, so if I draw, in this case, on the xz plane, I'm going to first draw the ellipse when y equals 0. So when y equals 0, we had drawn this one in already. I'm just going to copy that graph. So it was a narrow-looking ellipse. Something like this. And this is what we got when y equals 0. Remember, one of the things was it went as far down as -4 and as far up as +4. Okay. So for that ellipse, when y equals 0, let me scroll it down a little bit. So when y equals 0, the right-hand side of our equation was 16. If we compare that to the right-hand side of our equation now, it's 17 for this first ellipse. So that means it's going to be even bigger than this one. So I'm going to draw another ellipse, a little bit bigger than this one. So a little bit bigger than this one. Not too much, just a little bit bigger. A little bit bigger. So that's the cross section that we get from y equals plus or minus 1. And then from y equals plus or minus 2, we get an even bigger ellipse. So not that much bigger, but still bigger nonetheless, so a little bit bigger. So here is our next ellipse, a slightly bigger one. And this is the one that we get from y equals plus or minus 2. All right, now let's try to put this together and sketch out our full graph. So the graph of 9x squared minus y squared plus z squared, let's write that z better, plus z squared equals 16. So we've drawn a lot of cross sections. Let's try to put them together into this overall graph. Okay, so I'm trying to zoom it out a little bit so I can look at these. Okay, so we'll have a z-axis, we will have an x-axis, and a y-axis. And I'll draw the negative directions as well. So the negative z direction, the negative y direction, and the negative x direction. All right, so now let's try to draw in these cross sections into this 3D version of the graph. Okay, so let's just begin with one of these. So let's just say I begin with this hyperbola right here. This was from setting x equal to 0. And when we do that, we ended up with this picture on the YZ plane. Okay, so I need to be drawing this hyperbola shape on the YZ plane. Okay, so that means it's going to hit the z-axis here at 4. And then on the bottom, it's going to hit it at -4. At -4. And then I'm going to draw that hyperbola shape going down this way, and then on the top, it's going to go up. And it's going to go up. In fact, if I were to write the full coordinates for this point, I've only just written the z coordinate. The other coordinates are, just by looking at the hyperbola on the yz plane, I can see that the y value is 0. And I got this by setting x equal to 0, so the x coordinate is 0 at that point. And then for this bottom value is 0, 0, -4. All right, so maybe next if we do this hyperbola here. So this hyperbola is the cross-section from when z equals 0. So that one lies, this one lies on the xy plane. Okay, so on the xy plane, I have one of these intercepts when x equals 4/3. So x equals 4/3 might be somewhere here. So it might be somewhere there on the x-axis. And then the negative 4/3 would be on the negative side. Sorry, the negative side over there. And then we need to draw this shape. So when we draw this hyperbola shape, everything gets rotated. Because notice that the x-axis, instead of being to the right, is now over here, which is sort of like coming out of the page. So when I rotate that hyperbola, it's going to have this sort of shape over here. And in the negative side, I'll draw it with a dash line, because I wouldn't be able to see that when we look at this whole 3D shape. A dash line going this way too. That's my hyperbola going that way. So hopefully we can sort of visualize that these orange hyperbola shapes, that I drew, are on the xy plane, on the flat xy plane. Whereas the blue hyperbola I drew is in the yz plane. All right, so now let's draw the other cross sections that we got from these ellipses. Okay, so let's zoom in this time because I have all the ellipses showing up here. Okay, so what's going to happen is when I draw the first one, when y equals 0, so when y equals 0, so here's the point where y equals 0, it's like right at the origin. And the ellipse I get is from connecting this blue point at the top with this orange point, which is in the front, with the blue point there on the bottom. And then I go back and draw the back side of the ellipse, going to that orange point, and then going to the blue point. And now hopefully I can see that that's sort of making this vertical kind of cross-section to this solid. So if I similarly draw another ellipse when y equals 1 and y equals -1, well, the top point is on this blue hyperbola. And then when I come forward, the front of it is on this orange hyperbola. And the bottom is on the blue one. And then I draw the back. So the back is going to be back, hit the orange one, orange hyperbola in the back. Then back, and then blue one again at the top. The same thing is going to happen at y equals -1. The top of it is on the blue hyperbola. And then I come down in the front of the shape, hit the orange one, keep going down, then I hit the blue one at the bottom. Then at that point we start to go back, and that I draw with a dash line because I won't be able to see that. I'll hit this orange hyperbola in the back, keep climbing with a dash line until I hit the top. So let's draw one more of these for good measure. So if I draw the one at 2, the top of that is going to be in the blue hyperbola. I come down, we come down until we hit this orange one at the front, and then we keep coming down until we hit the blue one there at the bottom. The blue one there at the bottom, and now I draw a dash line because I can't see the backside. And I'm going to hit the orange hyperbola, keep drawing the backside, and I get this. And that's my general shape. It looks like I have these ellipse cross sections that get bigger and bigger the further out on the y-axis that we go. So just as a review, this shape is called a hyperboloid of one sheet. All right, so that is it for this example. In the next video, we will do a review example that integrates topics on parameterization, vector functions, and planes.